Here is part 2 of rational functions review. In part 1, we learned about what rational functions are, what are asymptotes, what is a whole, and how to relate all these things. Now, we'll specifically talk about rational functions of the type f of x equals to ax plus b divided by cx plus d. So it's a ratio of two linear functions. And in part 3, we'll discuss equations and inequalities related to rational functions. To begin with, we'll find x and y intercepts and asymptotes for the given function in general terms, and then we'll take up concrete examples. We'll also work backwards, that is, from the graph, we'll try to figure out the equation, and we'll take few communication questions to end with. So if a function is given as a ratio of two linear functions, in that case, we can find x and y intercepts very easily. Let's see how. So I'll just write here the things which we'll do. X intercept, y intercept, vertical asymptote, and horizontal asymptote, right? So these are the four things which will define this function if we really need to sketch it. For x-intercept, y value is 0, correct? So for x-intercept, what we know is y equals to 0. Now f of x is the y thing. So when we say y really represents the value of the function f of x. Y 0 means the numerator should be 0, right? So what we're looking for is to make ax plus b equals to 0. The value of x, which will make it 0, is just solve for x minus b by a. Does make sense? So for x-intercept, what we do is we equate this numerator to 0. We equate this to 0, correct? Now let's see what should be done for y-intercept. Now in case of y-intercept, as you know, x value is 0, right? Here the x value is 0. So in this expression, if I write x as 0, what do you get? You get b over d, right? So basically, if I write x as 0, you're left with b over d. So that becomes y-intercept. So this is your y-intercept. These two terms are 0. So y-intercept is y equals to b over d. Do you get it? As simple as that. How do we get vertical asymptote? For vertical asymptote, we have to equate denominator to 0, right? This portion. So for vertical asymptote, we write cx plus d equals to 0. Solve for x. X is equal to minus d over c. Perfect. So that is how you get vertical asymptote. And now let's look into horizontal asymptote. Horizontal asymptote is when x approaches a large value. It could be plus infinity or it could be minus infinity, right? In that case, what value will function approach? So in that case, our function f of x will approach ax over cx since b and d become small, x is large. And if you simplify this, you get a over c, right? So you get the horizontal asymptote as it is always written in terms of, it's a horizontal, so y value is constant, y equals to a over c. Do you get an idea? Right? So it's so easy to find all these values from the given function. And once you know these values, you can easily sketch the graph, right? So we'll take up an example now and sketch a graph. Let us say our function f of x is equal to 6x minus 3 divided by, I'm avoiding fractions, we may get sum. Okay, so let me put this as positive, we'll get one negative value. Okay. Now, we'll find different values and plot them. on a graph. In the next part of the video, we'll start with the graph, get the equation. So that is how you'll actually learn all about this particular function. So we'll begin. These are our simple steps. We'll begin right from the x-intercept. So x-intercept is when y equals to 0. That means the numerator is 0. So we say 6x minus 3 equals to 0. X equals to 3 over 6, which is half. Correct? So we get x-intercept, which is half. Let us say that is our x-intercept. Okay. Now, let's find what is y-intercept. Okay. So y-intercept is, let's write y-intercept, is when x equals to 0. So in that case, y is equal to 6 times 0 minus 3 divided by 2 times 0 plus 1. And clearly, y equals to minus 3 becomes the y-intercept. So let's say some point here. Okay, so these are randomly picked. Okay, now let's talk about asymptotes. Horizontal asymptote, okay, vertical first. So vertical asymptote, let me write in a different ink. Vertical asymptote will be when this denominator is 0, right? So we have 2x plus 1 equals to 0. So that gives us x equals to minus half. So that means a line right there. I mean, it's very close to this. So that becomes vertical asymptote. Now let's figure out what is horizontal asymptote. So horizontal asymptote is the ratio of these two, is y equals to 6 over 2, which is 3. So we are saying this is the y-intercept of minus 3. So I'll just take a point here and then draw y equals to 3. Does make sense? Now clearly these 2 points tell us that a part of the graph lies here. Is it okay? You cannot cross this vertical asymptote. You don't really have many options. What you do is you just connect these points. Do you see that? I will just connect these points. I'm sorry for that bad curve. However, we can go like this. Okay. So that is one part. Now, how do I sketch the other part? The most important thing here is this particular point. You'll also notice that this graph is symmetric about the point of intersection of the asymptotes. This is very important, right? So actually you could get this kind of like this, you can just, this point is point of intersection. So I don't have much space here, but what I'll do here is just sketch. So my graph will be kind of like this. Are you getting my point? So you can get fairly accurate graph without bothering much by reflecting it about this point. Do you see that? As think about 1 over x, which is symmetric about origin. Now you have got some transformations here. So it is symmetric about that point, and that brings to the end of this understanding about the function, right? What you also see here is that the function is increasing. So important characteristics of these functions are that they are either increasing all the time or decreasing all the time, right? So what we notice here is always increasing. Let me write down here, always increasing. Always increasing really means, in this particular case, from minus infinity to, the vertical asymptote was at minus half. Let me write here, to minus half, and then from minus half to infinity. Do you get it? So the graph of this function is always increasing. Of course, it cannot cross the vertical asymptote. Domain and range is another important thing to mention, right? So we'll write on the top, I'm running out of space here. So domain will be x belongs to real numbers where x is not equal to minus half in this case, and the range is y belongs to real numbers where we are looking at horizontal asymptote y is not equal to 3. You should remember that rational functions graph can cross horizontal asymptote, right? We learned it in part 1 of the video, but if it is of this kind, it doesn't, right? So that brings to the end of basic understanding about the rational functions of the form ax plus b divided by cx plus d. Now we will take up examples. I'd like you to copy these examples, solve them, and then check with my solution, right? So here we are considering a particular graph shown to us. This represents a function similar to what we learned, ax plus b divided by cx plus d. Now from this graph, you have to plug in the values and get your answer. So take your time and then I'll return with the solution. Thank you. Well, now let's look into the solution of this particular question. The question here is, consider the graph of function f of x equals to ax plus b divided by cx plus d. Describe the key features and write a possible equation for the given graph, correct? So let's begin from x and y intercepts. Let's follow the, some sequence which we did last time. So let's do this. X-intercept is what? So let me write down. X-intercept is at, this is minus 3, right? Minus 3. So we'll write this point as minus 3, 0. Y-intercept. Y-intercept is here, which is 0, 3. And then vertical asymptote. So vertical asymptote is this one, which is x equals to, let me write down here, x equals to minus 2, right? So x equals to minus 2, and horizontal asymptote, which is right there, y equals to 2. So we'll write y equals to 2. Is that okay? So these are 4 key features. Well, another key feature which always we should mention here is when you look at the graph, you can see it's always decreasing. So we say interval of decreasing. We'll write interval of decreasing. Now this interval is from minus infinity to minus 2, right? And, or you should say that union, so to include, right? Okay, this one. So from minus 2 to infinity. So minus 2 being a vertical asymptote should never be included. Now that is the interval of decreasing all throughout in the domains decreasing. So let's talk about domain. So domain of the function is x belongs to real numbers where x is not equal to the vertical asymptote minus 2. So when we say describe key features, it is not just these 4 points, correct? These 4 points which I'm going to write are equally important, otherwise you lose half the marks. I hope you get the point, right? So as far as range is concerned, we have everything except for 2, so y is not equal to 2. So that brings us to the end of our key features. Does it make sense to you? To get full marks, it is important to write all of them. But there are some more which you would always add on this, and that is, let me highlight, behavior near asymptotes. We learned in part A how to figure it out. Here you can see, right? So when you consider the horizontal asymptote, let's write down. So as x approaches minus infinity, y approaches what value? 2. But from below, so we write this minus. Do you see that? And when x approaches plus infinity, y approaches 2 from above. So you could write below or above also. Does it make sense? That was for behavior of near asymptote near horizontal asymptote. Now let's talk about vertical asymptote. Okay. So in case of vertical asymptote, you see that when x approaches -2 from left side, that minus, then y approaches negative infinity, and when x approaches -2 from the right side, it approaches positive infinity. Are you getting the point? So we say left side and right side. Now that really completes all the key characteristics of this particular graph. And one more, if you want to wish, is that the graph, should I write? Okay. So we say graph is symmetric about this particular point, which is -2, 2. So all these graphs which are of this form are symmetric about this point. That is to say that if I draw a line going through it, we'll find a point which is same distance away. That is the kind of symmetry we have. Do you get it? That is very important to understand, right? So, well, that's it. Main thing is to write the possible equation. We are just forgetting that. Possible equation. Now, all these features can help us figure that out. So what we do here is, I'll show you how we should do. So I'll write in the light color because I'm sure I will have to correct it the way I'm going to show you. So this is a learning process, correct? So we say the function f of x is equal to, from where should I begin? Let's start from the vertical asymptote, right? The vertical asymptote is at -2. We could start with horizontal also, which is at 2. Okay. So in this, if I say horizontal asymptote is at 2, it means what? It means this ratio is 2. So I'll write 2x plus b over cx plus d. Do you see that? It's like a process. Now I say that the vertical asymptote is -2. That means -2 should give me 0, right? So this is the ratio I'm talking about. So -2 can give me 0 here only if I have if I put 1 here, and if I write -2, d should be 2. Is that okay? So this was regarding we just took horizontal into account. Is it okay? Now we'll talk about the vertical asymptote. So we say, well, it would be 2x plus b divided by. Now this vertical asymptote should be -2. So if c is 1, so it should be x plus 2. Does it make sense? So c becomes 1 for us. Right? So in this case, we are assuming c to be 1, and it works actually. Actually, instead of c, I should have written 1 only. So we have x plus d, right? Now for -2, I want 0, so I get this part. Okay, so I've taken care of vertical asymptote. You don't have to write all these equations. Okay, now let's look into the intercepts. So if x is 0, we need what? Y-intercept, which is at 3, which is 3 times. So if this is 2, that should be 6. Does it make sense? Right? So this should be 6, correct? So what we will do is, taking into this consideration, so we say, well, it should be 2x plus 6 over x plus 2. Does it make sense to you? Now, if I say, now my check is this. This is my check now. Check. So I'm checking if my y value is 0 for -3. So if I substitute -3 here, it works perfectly fine, correct? So now I write down my function f of x as equal to 2x plus 6 divided by x plus 2. Do you get an idea? Right? So again, let's begin. When we talk about this horizontal asymptote, this ratio is 2. Now, if we talk about the vertical asymptote, you could start from anywhere. For -2, it is 0, correct? Then you could do either this intercept or that. We prefer to put x as 0. And y-intercept is 3, so this should be 3 times 6. then that becomes a checkpoint, the last point. Whether for minus 3 do we get 0? So minus 3 gives us 0, so that is correct. So go through this step of working out your equation. It is not difficult at all, but I hope it gives you a good sense. Correct? So from a graph, it's easy to figure out the equation if you follow some steps. Okay, so let's move on and see what do we have next. So here is a question from previous test paper. I would like you to copy this test question and then we'll work out a solution. Okay? So let's find the solution for this question. For the function f of x equals to 7x minus m over 2 minus nx, find the values of m and n such that the vertical asymptote is at 6 and x-intercept is 5. Okay, so f of x is given to us as 7x minus m divided by 2 minus nx. Is it okay? Now we are given that the vertical asymptote is at 6. That means the x value is 6. Is it okay? Horizontal no. X-intercept is given to us. X-intercept. That means y is 0 is 5, 0. Does it make sense to you? So we are given these two things, x-intercept and the vertical asymptote, right? How will you do it? So it's not difficult at all. For vertical asymptote, we'll check the denominator. Correct? So we are checking this part. That should be 0. So we'll substitute x equals to 6 and say 2 minus n times 6 should be equal to 0. Does it make sense? It is much simpler, right? So we can rearrange. We say 6n equals to 2. N equals to 2 over 6, which is 1/3. Correct? So we got one part. Now for the other, what can we do? X-intercept is when y is 0. So that is to say, numerator should be 0. Does it make sense to you? So we say 7 times x value is given to us 5 minus m should be 0. M equals to 35. Done. So it's that simple. So you just substitute these values for x and solve for the unknown variable. I hope you appreciate it. Let's move on. I hope I made it simple for you, not difficult. Another question here is, explain if this function f of x equals to 7x minus 6 divided by x plus 1 satisfies the following conditions. Horizontal asymptote at y equals to 7. Graph is decreasing and approaching 7 as x approaches infinity. We'll assume positive infinity. Vertical asymptote is at x equals to minus 1. Well, you could do it, but what I will do, easily sketch it. So it'll give me a practice for sketching. What do we see? Vertical asymptote is denominator equals to 0, minus 1. Makes sense? Minus 1. So this is correct. So vertical asymptote is when denominator is 0. Perfect. Horizontal asymptote is we'll check this ratio, 7 over 1. So let me draw here horizontal asymptote, 7. Anyway, this is not given to us, we'll not bother. Now we'll find the x-intercept. Okay, so, or y-intercept, whatever, right? So if I suppose put x equals to 0, if I put x equals to 0 in this equation, that means f of 0 is basically minus 6. So that means the y-intercept. Is that okay? So y-intercept is minus 6. That is somewhere here. We got y-intercept as minus 6. And what are we given? Horizontal asymptote is 7. That is correct. We just figured this out. Yeah, y equals to 7. Now, graph is decreasing and approaching 7 as x approaches infinity. Now, if that is my y-intercept, let me also find x-intercept. I don't need to, but just to complete it a bit. Okay, so we'll find x-intercept also. For x-intercept, numerator should be 0. Is it okay? Because we want y to be 0. So we get 7x minus 6 equals to 0. X is equal to 6 over 7, which is slightly less than 1. But it is positive, somewhere here. Is it okay? Now that clearly indicates that the graph should be like what? So let's sketch the graph now. So if you sketch this graph, you will actually get something like this. I mean, okay, let's combine these two. So in such examples, we are not crossing the asymptotes. Do you see that? And this half will be kind of like this. Does it make sense? These points being symmetric about that point. Okay, so take care. If I have like this, these are equal. Think like this. Then it's perfect graph for me. Now what do you see? Graph is decreasing and approaching 7 as x approaches infinity. Well, that is wrong. So this part is incorrect. Graph is increasing, not decreasing. So this part is not correct. So you can very clearly see that as x approaches positive infinity, correct, f of x is increasing. In fact, this graph is always increasing. Do you see that? Always increasing. So this statement is wrong. To make it like this, what will you do? To make it like this, what will you do? You will actually put a negative sign there. That's it. So I could define g of x equals to negative of 7x minus 6 divided by x plus 1 to get decreasing graph. So that will be decreasing graph. Do you get my point? So just negative means it will just flip everything upside down. Does make sense? So that is how we should be doing it. So definitely this equation is not correct for the second condition given to us. To make it correct, which may be a part of question, we just need to reflect it. Okay. Another question here is, write rational function that has domain of this kind and no vertical asymptote. Okay. Now here is a review of part 1 and part 2. So we are not restricted only to what we learned about ax plus by, I mean linear things, okay? So consider this to be review of part 1 and part 2. Is it okay? And part 2. So earlier I was thinking of combining both, but it was too lengthy. So let's read and answer these questions. Write rational function that has a domain of x belongs to real number, x is not equal to minus 2, and no vertical asymptote, right? That's why. And no vertical asymptote. You learned that ax plus b form will always have a vertical and horizontal asymptote. As soon as you see no vertical asymptote, it means it's a different form of rational function, correct? Is it right? So that means what? If we have a discontinuity and no vertical asymptote, we are talking about a hole. So this function will have hole at x equals to minus 2. Got it? So a rational function that has a domain of something like this and no vertical asymptote could be like this. Is it okay? So we could write this function f of x as equal to, since I want to make this part as a whole, so we could say that this could be kind of like this. So domain is all real numbers and no vertical asymptote. So we'll have this factor minus 2 common. So we could do it by x square minus 4 divided by x, and we want minus 2, x equals to minus 2 to be whole, so we'll put x plus 2. So that minus 2 will give us. So this could be written as x plus 2 times x minus 2 divided by x plus 2, correct? And that really means that these two things will cancel off. And so you really have a function which is x minus 2, where x is not equal to minus 2. And if you want to sketch this function, then it's a straight line, correct? X minus 2. So it's a straight line kind of like this. But at minus 2, there is a hole. Does make sense? So this is at minus 2. And obviously the value is minus 4. So that becomes a function which is going to satisfy that condition. Now here is a real test problem for you. So what I've done here, added one more condition. So it says, write rational function that has a domain of x belongs to real numbers where x is not equal to minus 2 and range between 0 and 1, 1 included. So I've restricted range also. So what you find here is that the range is restricted. Okay, so what could be the function? Since we are looking for a domain with a restriction, we can say g of x is equal to, but we are also looking for a range which is kind of like this, right? So we do have a factor which is x plus 2 in the numerator and x plus 2 in the denominator. So they will cancel out to give us that restriction. And to figure out the next one, we could have reciprocal of x squared plus 1. Do you see that? So here if x is 0, we do get a value of 1. But if x is large, it is approaching 0, right? So the function is this. Do you see that? So you could write g of x equals to x plus 2 over x plus 2 times x squared plus 1. So that is how you're going to solve this particular question. I hope it makes sense, right? Now, okay, so we already done that part. Okay. So that brings us to the end of this particular section. And I hope you learned all about the function when it is given in the form of ratio of two linear functions. So now we'll take up part 3, in which we are going to discuss equations and inequalities related to rational functions. I hope you are enjoying this journey with me. Feel free to post your questions and suggestions, and if you like and subscribe, that'll be great. Thank you, and all the best.